This is the Chapter 4, Lesson 1 homework video for AP Stats, and we're going to look at things a little differently this time. So we're going to look at them in terms of a problem that our goal would be able to answer at the end of this lesson. So here's our problem. You're trying to prove to the administration at SHCP that the students are not satisfied with the food sold at lunch. So we want to know all the information about the students at the school in order to present that to the administration. You don't have time for that. Nobody's got time for that. So you're just trying to find the best statistical method to use to sample in a way that reflects the population, meaning to gather data from a smaller group of students that would objectively reflect what we're trying to measure, which is all students' opinion at the school. Now, we're concerned that a couple things might affect this. Grade level, so whether you're a freshman, sophomore, junior, or senior, and your gender, male or female. So let's look at how we would go about doing this. So two possible solutions. Show up to school and ask the first 80 students that walk onto campus. Or two, get a list of names for each student at the school and randomly select 80 students. Email these students in order to get their opinion on food service. Pause right now thinking about what are the issues with both of those. So our big idea here is how can we conduct surveys experiments in a manner that produces reliable and unbiased data, so that we can accurately answer a question about a population. Our population here would be all of Sacred Heart students. What you're trying to do is collect the smallest sample possible to get an accurate reflection of what people really think. And again, we do this because it's not practical for our school where there's over 1,300 students, but it's even less practical if we want to say, like, who's going to be the next president of the United States. We can't contact everybody. So population and sample. Population is what we want to know about. The sample is what we collect and gather data about. So that's an important distinction there. Now this is a survey or a study because what we're doing is we're just gathering information. We're not imposing a treatment. We're just asking people a question to gather information. That makes it a study. So our goal here is to, let's talk about what not to do, So we want to avoid bias. So what could lead to bias? Bias would mean the data we gather is not valid. It does not accurately reflect the population from which we're trying to measure it. So we'd be gathering data that didn't reflect the true opinion of all students at Sacred Heart. A convenience sample is one problem. So if we just go with the first 80 students that come on campus, then what will happen is we'll likely have undercoverage, meaning we're not covering a certain group of students that we would otherwise if we were doing a more representative sample. So students that arrive later likely wake up later and have less time to make lunch, so maybe they tend to eat lunch at school more frequently. They'd have a more informed opinion because they have to eat that lunch. They have to look at what's offered each day. So that would lead to the survey overestimating the student's satisfaction with the food offered. So if you're trying to say, hey, we need new food service, that data could actually be an overestimate of how happy people are when you're trying to show them that people are unhappy. So we should find a new sampling method. Shoot that one down. Let's look at solution number 2. Now solution 2 is get a list of names for each student at the school and randomly select 80 students. Okay, so we're randomly selecting them. It's not a convenience sample. Email these students. What could go wrong there? Pause and think. As you think about what might be an issue with that sampling method, think about what the bias might be. So think about what lurking variables we may have. That means it's another explanatory variable that might be causing a change in the opinion. So we want to avoid bias. So something there is that we might not get a representative number of males and females, or freshmen, sophomores, juniors, and seniors. So in this case, a simple random sample, where we just take 80 random names, it's like if we placed all 1,300 plus students in a hat on the same size slip of paper and drew 80 students without replacing them. That'd be one way to do it. That would not be too practical in this case. So we might have a list that's on the computer already, number them, and then use a random number generator to generate 80 unique random digits from 1 to 1,300, whatever the number of students is. But we'd want to do that without replacement because we wouldn't want to ask any student twice or be counting their opinion more. Now, that doesn't count, this does not account for the fact that we think gender and grade level might be affecting our result. So what can we do there? Well, we know first off, emailing the students, it's voluntary response. Students don't have to reply to an email. Students that don't check their email wouldn't respond. Students that have a strong opinion would be likely to respond, and those without one may be unlikely to respond. So maybe students that are really passionate about how much they dislike the food will respond, and this would be an overestimate. We also haven't accounted for those lurking variables of gender and grade level. So what could we do differently to get a representative sample, grade level, and gender? One strategy is a stratified random sample. So if we think that a characteristic of the population affects the outcome that we're looking at in a systematic way, so if we think gender affects outcome or grade level, for example, we can choose those strata, so grade level, and we can then take a random sample from each of the strata. So we can break people up. So if I thought, for example, that the county within which you lived in California affected who you're likely to vote for governor, I could sample the same percent from each county and then take an SRS of each county. And that way I make sure that I have members of each county represented in my data. So here are radio stations breaking up population into geographical regions. And then because they're thinking culture is likely to affect whether individuals like a song. So that's a stratified random sample. Strata would be a quality that we think is affecting our outcome. Stratifying would mean separating based on that category and then choosing a representative, proportional SRS, simple random sample, from each of those groups. Another strategy is the cluster sample. A cluster sample would be separating the population into groups, each of which mirrored the characteristics of the population. So if I was looking at race as affecting outcome, and I had 30% Caucasian and 40% Asian and 20% Hispanic, Latino, and I had 10% Native American, then I want those same proportions, those same percentages, to be represented in each group that I made. So think of them as like a little mini representation of the population from which they came. Then what I would do is number each of those clusters or groups and then randomly choose an entire cluster or an entire group and ask everybody there. One where this happens a lot is airplane flights. They don't want to delay every flight for a survey, so they'll randomly choose one flight and ask everybody on that flight to fill out a survey. That way they don't slow down all their traffic. Just one flight is slower than it would usually be using a cluster sample. Now the goal here is to be as objective as possible. That means to have our data mirror the population as much as possible, so we can use the results to infer accurate information. So we want to avoid convenience samples. We want to avoid voluntary response samples where non-response is a possibility. Those are going to lead to bias. Those are incredibly likely to lead to bias. We want to randomize. So random is the key thing to this chapter. And random doesn't mean you and your friends just walked into school and you're wearing the same pair of shoes. Random here, we have a strict definition for it in stats, and we'll keep exploring that as we go. So, objectivity means a lack of bias. So just trying to pull out what's really going on, to see through everything else that's somebody putting a spin on it or anything that's not representative of our true population. And that means avoiding undercoverage, which means parts of the population are not represented. Avoiding non-response, ways of sampling that would allow people to not respond, and avoiding response bias, wording a question that leads to an answer. In a court case, that might be like leading the witness, where you're saying things in a way to push people towards an answer you want. That would be, for our example, saying like, don't you think the food service at lunch is horrible? You know, like you're implying you're already kind of leading them towards the answer you want, as opposed to just asking them, what's your opinion of the food service? You could also be the bias the other way. Don't you think the food service this year is just the best thing ever? So both of those first and third questions are biased ways of wording the question. So I'd like you now to take a look in your book and read over the summary for 4.1, look over some of the examples to get an idea of these different sampling methods, and then I want you to design a strategy using a stratified random sample that would most objectively gather opinions about what the population of SHC students thinks about the food service. Now you need to keep in mind that gender and grade level may be lurking variables. How can we account for these? Clearly identify what our two strata are, or the characteristics that may affect the outcome of our study. And then explain how your design is most likely to be representative of the entire population of SHC students. Remember, that's our goal. So pause here, answer the free response, and then push play to get your multiple choice question. So which of these methods, notice that stratified random sampling is not included here, but which of these 5 methods would be best to allow us to have equal representation from each grade level? So pause here to look at these answers and submit your multiple choice and free response.